Okay, so good morning. The class is called, I don't know, Introduction to Service Design, right? And today we don't start in the middle of the presentation. We want to have a look at one type of programming, let's say, paradigm for the web. They are called RESTful web services. I will tell you something about web services. I will tell you something about REST, and hopefully by today we'll know everything about how to program the modern web, let's say. Then in the next classes you will see another kind of web service, which is then a more complex type of web service, more for, let's say, enterprise applications with all the heavy reliability and authentication mechanisms there. Okay, let's start. So background. I make a very simple example. We want to talk about programming on the web. So what does programming mean? I think did you already program distributed applications like in Java, RMI, or Corba in C++? Nothing. So, but you programmed Java. So there you usually you develop different classes, and you allow one class to invoke methods of the other class, right? And this is basically an interaction between two objects or two pieces of software that is going on and running on your machine. If you want to do this in a distributed manner on the web, somehow you need to do the same thing. You want to have one class or one piece of software talk to another piece of software. It's just that in between there is not just your programming environment, which is Java or C++ or C# or JavaScript, but there's the network. So there's the web in between. What does this mean? You know, the web means, or whatever network means, communication. So instead of direct invocations, you need to be able to send messages to your target. It's called web service, but the piece of software that you want to talk to, you send a message to it. And there, in the web service stack, there are different approaches to this, different abstractions. There are two big schools, let's say. One is called, or let's say one uses plain XML over HTTP, HTTP being the basic communication protocol of the web. XML you know from last time, so I'm not going to introduce anything about XML again. And this is the very plain, simple use of the web and direct communication between services. And then we have the so-called web service, WS star standards, which is the whole stack you can see here for, Maurizio called them big web services. Today we are going to look at this, let's say, easygoing way of doing web services, and then in the rest of the classes you will also see the heavyweight version. So as I said, programming on the network means sending messages. We gave you all the introduction about XML, not just for fun, but because this programming today typically means exchanging pieces of XML among your application and the remote application. So you send an invocation, for example, in XML, asking for, I don't know, asking for data for a list of books, and then you get back XML containing the list of books, for example. So you have a computer A, you have a computer B, and you exchange messages. XML has this benefit, I don't know whether you talked about this, that it's platform independent. It's just a document format. It's a means to exchange data over a communication channel. Here, for example, you can have your application in Java running on Linux, or you can have another application developed in Perl and running on, I don't know, Windows or whatever machine. Nobody cares. The important thing is that all the pieces of software that want to communicate with each other, they just stick to the same, it's called the protocol on the network, and they know how to talk to each other, and they use the same data formatting paradigm. So this is good. So whatever language you like, if you want to program a distributed software with your friends, just use whatever you like, but stick to the common format, common XML, for example, and you can talk to each other. Then there are three key approaches to programming this kind of scenario. One is which I will explain a little bit, XML-RPC. RPC is remote procedure calls. I explained you Java classes that invoke methods of other classes. This is called, it's like a procedure call, when it's a direct call of the method of another class. And you pass parameters in input and you get result parameters back. XML-RPC tries to mimic exactly this over the network. It's just, it serializes, it's called, it serializes your invocation in XML, sends it to the destination service, the service interprets it, produces a result and sends the result back again in XML. It's very trivial and it's really simple. It is really just like regular programming with procedures. Then we have SOAP. This is what I'm not going to explain today. This is what you will see in the rest of the classes. It's called Simple Object Access Protocol, but you will see it can be very complex also. And yeah, it offers much more flexibility and much more tricky things than just plain RPC. And then we have REST. It's called the Representational State Transfer. It's, I would say, just a completely different philosophy of doing distributed programming on the web. But you will see that actually you know this philosophy very well. So you will see it's a very interesting paradigm. But first, just to have an idea of how the very first ideas of distributed applications on the web, how they were implemented, let's have a look at this XML-RPC web services. So, as I said, it's a remote procedure call. Instead of something local, you send a message to a remote service, invoke the service there, and get result back, and then you can interpret the results. It's more or less as if you had the procedure locally there, but instead of invoking it directly, you send messages. So requests are encoded in XML, and payload is sent via HTTP post methods. So HTTP, you know, is the Hypertext Transfer Protocol. I will come back to this later. And there are different methods. One is the post method. When you do a web application and you have a form in your web application where you can fill data, then the browser, when you hit the submit button, the browser issues a post message. The post message allows you to talk to a remote resource and to send a payload in the body of the message. And this is how XML-RPC works. You have the request header, and in the payload you have the actual request of the invocation. The destination web service then reads this XML, executes the command, and returns the result in XML. So in practice, this looks like this. So very trivial example. The part here is HTTP. HTTP is plain text. You say post, this is the so-called method. You have the protocol version, and then you have the resource, it's called. I mean, it's the path on the destination server. Think about the web, just in general websites also, it's the same thing. The host is UniTN in this case, the agent is you, the content type in this case is text XML, and so on. And this is the body. So this is actually what you send through the network to the destination service. This is what is interpreted, and this is then what is executed remotely. So in this case, it's really trivial. Method call, method name, weather, get weather. It's really like the invocation of a method of an object. And then you have also parameters, Aberdeen as the city, for example, and what you get back without doing anything on your own machine. This is executed remotely. What you get back is horrible and wet. So Aberdeen in the UK, so we don't have anybody from the UK here, so we can say it. It's quite likely that in Aberdeen it's really horrible and wet today, just like here. What is XML-RPC in this case? First of all, it's this here. It tells you, you send plain XML, you send HTTP requests, and you have in the body, you have plain XML. The XML, you have here these XML elements. last time, I think you learned that XML is just a meta language. So it only tells you that there are elements and attributes and structures and whatever. So it doesn't have any meaning. XML-RPC is a standard that gives a specific meaning to a specific set of attributes. And here we have, for example, not only attribute, but also the elements. Here we have one element, which is a method response. Before we saw the method call element with method name, parameters, and so on. So it's very, very simple. What you would do regularly with object dot, or let's say by writing weather.getWeather in Java, here you have to describe it a little bit with the XML. You send it over the network, it's interpreted remotely, executed, result is packaged, and sent back to you. And that's the logic. What's the benefit of this? I mean, it's an overhead. It's much easier to say just weather, get weather. But the fact is that in this case, the assumption is that you don't have the weather object on your own machine. It's executed somewhere else and maybe operated by someone else. And maybe it's very, very complicated. So you have a huge benefit in using this service for free or for payment, whatever. But you don't have to care about how the weather service is implemented. You just need to invoke it. What's the pro and what's the contra? So the pro of this XML-RPC approach is that it's really trivial, actually. So as I said, it's really method invocations. It's very simple. It uses standard technologies of the web, and it's easy to learn. It doesn't need any big IT infrastructure. You don't need to install middleware or whatever new protocols on your machine. The downside of XML-RPC is that it's a bit maybe too simple, too trivial. HTTP can do much more. This is what we will see today. And XML-RPC just uses the post request. So all the messages back and forth between you and the remote piece of software, the remote service, it's always a post request. It's not very efficient because we will see there are much more interesting operations also. And it's limited to this RPC architecture. So that's why today we want to have a look at the RESTful web services, where we see that we can do much more with plain XML and with plain, but not only XML, and with plain HTTP. So what is REST? It's not a standard. It's not a language. It's actually nothing I can really give you. I cannot hand you out something like with XML-RPC. I can point you to a W3C specification. You go there and you read the text like the HTML specification. In this case, not really. It's a convention. It's an architectural style, it's called. So it's just a way of implementing a remote web service, a remote piece of software, using standard technologies that are already there. So that's the interesting thing. So the idea of REST is that everything you need in order to do the distributed computing is already there. The objective is basically the same. What I call a remote web service is exposing resources on a networked system. So the network is the web in our case. Resources are, I don't know, web pages, books, cars, whatever. We will see examples. And yeah, as such, you will see this is only a design guideline. Today I will just tell you how to implement something using HTTP, using XML, and you can do very good, very stable, and very scalable distributed computing, let's say. The origins of REST are typically people say REST comes from this PhD thesis by Roy T. Fielding, who did a PhD on the topic, and he came up with this architectural style and the design guideline for networked software applications. But actually, it depends. The key ingredient of RESTful services is just HTTP. So it's basically the internet. So this goes back to the beginning of the 90s, let's say. It's just that people started doing websites and web applications, and then when people started programming also over the web, the first ideas were this XML RPC approaches, and then we had the SOAP web services also, which have this object-like interpretation of remote invocations, object dot method and so on. And at some point, Fielding, he just said, actually we don't need all these abstractions on top. We don't need all these new protocols on top. We can just do distributed computing with the web as we have it. And this is then the content of his thesis. And he shows there only, as I say, these guidelines about how to do it. So REST, we will see, it's a client-server architecture, just like a website. You have, as I said, resources, pages, and you only transmit over the web representations of the resources. We will go into the details of all this. And when you develop a website, did you, okay, let's say application state is what you need to track off when you interact with a web application, for example. You log in, then after the login, maybe you can place an order. Let's think about Amazon. You go to Amazon, you have to log in first. Then once you are logged in, you can select books that you want to have. You put them into your shopping cart. Once they are in the shopping cart, you can select the checkout button, and you can pay and so on. But you see, there is some kind of order. You cannot do this randomly. You cannot do checkout before placing an order into your shopping cart, and you cannot view or delete things from your shopping cart before you added things to the shopping cart. So there's an order. And this is kind of the state. So in each time of your interaction with this website, you are in some state. And the state tells you whether you can do one operation or whether you can do another operation. And this is important. And in REST, one of the principles is that you keep this interaction state only on your client side. So you don't have the web server tracking what you are doing. In Amazon terms, it means the web server will not keep the shopping cart for you. You have to do it yourself. This is one. And then finally, the client state may evolve, as I said, by navigating. You navigate through the Amazon website, and while you navigate, you see new things, you see new opportunities, you see new operations that you can execute. And the same happens for web services. So imagine just a regular web application, and instead of programming this kind of logic for a human who gets HTML and who gets pictures and who gets nice, I don't know, charts that humans can read and easily understand, you do the same just in plain XML for a machine. So this is the big idea behind. You have a same software structure like a website, but they always give back XML or similar representations. You have links, you can navigate. It's just that you are no longer a human person, but you are a piece of software yourself. So what is a resource in this context? Resources are unique. They have representations, they are attributes. They may have a schema, they provide context. In essence, what's a resource? A resource is when you do data modeling, for example, then you identify the entities of your application. As I said, Amazon, let's take Amazon. We have books, we have CDs, we have, what else is there? I don't know, there's hardware, and these are resources. And you group resources by their type. So this is, you can describe the book in terms of, well, there's the full content of the book, if you want. There can be a PDF of the book. There can be just the so-called metadata of the book, the author or the authors, the publication date, and all these additional information. Books are resources, and then around these resources you have attributes, you can have representations, as I said, PDF or Kindle version of books, and so on. examples, yeah, I don't know, websites, resume, aircraft, songs, and so on. Also a song. If you think you have a web server with MP3 songs there, I can give you the real streaming of the song, of the MP3. I can give you a summary of the author. I can give you the lyrics of the song, and so on. This is what is called the different representations of the resource. So resources are entities, and then representations of these entities, they give you different views. In this case here, we have a researcher here, Jane Doe, engineer. Imagine this, that the resource is the user profile. So how do you deliver the user profile to your clients now? Probably this is what is the traditional, let's say, approach. You have your resume written in natural language text, and this is what you send around if you look for a job. But you know, when I could also format the same resume in XML for, I don't know, some machine processing. I could have just a picture of the person we are talking about. Then we could have a printed, I don't know, a book or something about the resume. We can have an audio, like, I don't know, something where she presents herself and it's an MP3 version. The key idea here is that the resource is unique. It's stored somewhere in the network on a web server. And you don't really interact with the resource. You never get really access to the user profile. In technical terms means the user profile is in a database. I don't give you access to my database, full stop. But I give you access to different representations of the data I have in the database. I extract the data, I send you XML, I send you JSON, I send you natural text, natural language text, and so on. So this is a very important distinction, because you can have one resource, the user profile of Jane Doe, and you can have different representations. And depending on who you are and what you understand, you might want, for example, to have the CV in English or in Italian, in German, or whatever. So you can negotiate the representation. This is one of the key principles. Okay, then, in order to really have also the technical background, just a short recap of HTTP. I think you should know this, so I'm not going to ask whether you remember, but HTTP is the Hypertext Transfer Protocol. And it's basically the protocol at the application level. If you remember, there's the ISO-OSI reference model of network protocols. You have the cable, we are here, physical, then we have different levels of protocols when you send a message. And you know how this works. When you have each level here adds a piece of control information to your message. You want to say hello, then you need to, at the application level, for example, you have then at the application level, you need to put some control information there. You need to say the address, the destination person you want to say hello to, for example. Then you go down at the presentation level, you add again a header that tells something about the representation, XML and so on. Session, if there is a continuous communication between you and the person you want to talk to, and so on. This is the general ISO-OSI reference model, but in the web we only use a simpler version, the TCP/IP protocol, where we have the Ethernet at the lower level, or now we also have GSM for mobile internet and so on. Then on top we have the IP protocol that gives you the IP address. Then we have the TCP or UDP. These are this is the transport layer. These are protocols for, they just care about something comes from top, it's data, I need to package it into some pieces and send it over the network. TCP is a network with that is reliable, it's called, which means it guarantees you that if you send a package, it will also arrive, while UDP is not. And then on top, we have these application level protocols. We have FTP for file transfer, we have SMTP for email, for example, and we have HTTP. This is the Hypertext Transfer Protocol. So this is the lowest level of abstraction we will go today. On top of this here, we would have the XML-RPC protocol, which is another level of abstraction there, because it's based on HTTP. And what does it mean to use HTTP? So how do these headers of HTTP look like? It's basically a set of, or not a set, each header has one request method, and these methods are actions. The most famous action is called GET. It requests a representation. So if you access a website, your web browser, you just write the address, you push enter, and the web browser issues a GET HTTP request to that URL. And the result is it gets back the representation of the website. Then there is head and post methods, put and delete, quite intuitive. Head gives only metadata about the resource. Get gives you a representation of the resource. Post allows you to send a resource to the web server. Put allows you also to send a resource and to create a new resource that then permanently stays on the web server. And delete allows you to delete this. This is all I want to say now. So HTTP, plain text protocol, methods that have basically read, write, delete, and post or put, update. Okay, REST principles. There are 6 principles that express this architectural style of RESTful web services. One is resource identification, meaning we need to identify, as we did before, which are the resources we want to talk about. Then addressability, we need to enable somebody to refer to these resources. Then statelessness, it's what I hinted at before. So the RESTful architecture says that they don't keep, the web service doesn't keep any state on your behalf. You have to do it yourself. Then we have the resource representations. We intuitively saw this already. We have links and connectedness. You can have links among resources. It's useless to have just the resource of books somewhere in the web. So probably you want to link the book resource with the user who bought the book or so on. And then finally, the uniform interface. The uniform interface is more or less what I showed you just right now with these 4 or 5 HTTP methods. Let's go into these details. Resources must have at least one uniform resource identifier. So this means simply, if you are not able to identify your resource, either it's completely useless or it's not a resource. So there are 2 types of resources that are usually used, so-called URNs, uniform resource names, and URLs. The URLs are more famous, which are the uniform resource locators. So on the web, you use the URLs. You write a URL, and then there is a domain name server that interprets the URL, translates the URL into an IP address, and then you can establish a connection, a direct connection with the server hosting your resource. A URN can be anything. It could be your name, but your name is not unique, so it's not a URN. There are many people probably around the world with your exact same name, so it's not a good candidate. But books, for example, they have the ISBN number, and it's a worldwide unique number. Or there's now also the digital object identifiers, DOI. There are some unique identifiers that are really unique at world level. Once you know that number, there's no doubt about which resource you're talking about. And then the important thing is that you need to have one URI per resource, but then also each URI only talks about one resource. You don't have a mess where you have one pointer to a book, but the book also contains CDs. What identifier is this? You need to be, let's say, clear or consistent. Then addressability means that, as I said, you can really reference these objects somewhere. So the object, in our case, or the resources, sorry, they are on the web. We know how we can name them uniquely, But we must also be able to access them. So we need to be able to address them. So like on your file system, you can address them by the path of the files in your file system. The cells in a spreadsheet, they have just the bidimensional, how is it called, coordinates. And Google is addressable. You can just put your search string there, and you can save it, and it's kind of an address. Each time you put the same search string there, you get to the same destination. I'm not sure this example is really good. So it was already there. So it's always tricky to use the slides by somebody else. You know, Google evolves over time. So maybe what you do today will be different in 1 year. But it's important. So accessibility is the key. You know the URL. You know how to access your resource. That's the message. About statelessness. So what is stateless now? Let's again use Google. Imagine this is the Google website, and this is your web browser. You have the search form there. You can input whatever query you like. The idea of statelessness, or the property of statelessness, is that you can issue as many queries as you want. You will not change Google. So, and it's not important whether you invoke Google first with jellyfish, la medusa, and then with mice, for example, or the other way around. You will always get the same results. So there's no order between invocations. Google doesn't remember what you did before, or doesn't expect you to do something afterwards. It's here, stateless. It doesn't care about what you do. It's up to you to keep track of this. But what you can do here, for example, is you can navigate. If you look for mice, then you can navigate from one result page to the second one. Looks like state. It is state, but it's your state. In the sense that Google, you query Google for mice, Google gives you a result with just links to more results. But whether you use them or don't, Google doesn't care. But then if you click on the more link, then you issue a new request that is then processed, and then that tells Google to fetch now results from, I don't know, from 20 to 40, for example. Instead of the first 20, give me the second 20 results. That's it. But Google doesn't know. It's just each time you issue the query, you tell him, give me now, you tell the engine, give me the first 20, give me the second, give me the third 20, and so on. So this is the idea of statelessness. And this is good. So why is stateless good or important? Because, you know, if Google doesn't need to track what you do, and if Google doesn't need to store any data on your behalf, it's somehow lightweight, right? It's your problem to know where you are in the navigation, if you are on page 5 or page 10. It's not Google's problem. You can easily manage your own data. But imagine Google, that they have, I don't know how many million, maybe 1 billion users. It's just not imaginable that they can store the interaction, the navigation state of 1 billion users. It wouldn't make sense. So you see, so Google is one of the most scalable applications we have on the web, just because they are stateless. They don't keep anything, any data on your behalf. And you told me that you developed some web applications in the past, right? Who developed web applications? Very trivial ones. Raise the hand. Let's see. Okay. Did you use cookies, or did you use session parameters? Yeah. Session. Yeah. Okay. That's exactly the problem. Sessions. Does everybody know how sessions work? Okay. Good. Then. No, but the problem, security is then another aspect. So let's forget about security. You're right, and this is also something. But no, the problem with sessions is this, that if you use sessions, then you do exactly what I just said Google is not doing. You keep state on behalf of the user. how do the sessions work? Amazon. I go to Amazon, I log in. When I log in, Amazon, the web server of Amazon assigns me a session identifier. It's just a number. And it sends me this identifier via the HTTP response, and I store it on my own machine as a cookie. Just locally I store it. And then from then on, each time I talk to Amazon, my web server automatically adds this identifier to the request. So each request from that moment on will just carry this session identifier, it's called. What does the web server do with this session identifier? It essentially creates some space on the web server for me. What's that space? It's the shopping cart. The shopping cart with the books is, for example, then stored on the web server, and then each time I talk to Amazon, the session identifier is sent with the message, and the web server is able to understand who I am and which shopping cart I'm talking about. So if I say checkout, because of the session identifier, they know which books I want to check out. But you see, books is maybe just a very simple set of ideas, but the state of my interaction could be much more complex. And as I said, Google doesn't do this and is highly scalable. Amazon is also scalable, but they still have this problem. They could be more scalable if they didn't use this. So the fact is, HTTP per se is stateless. Doesn't require anybody to store this interaction state anywhere. With cookies and with websites, with sessions, we break this. We break this, and this can be an overhead. So it's hard to make very scalable websites that use sessions. Then, how do we, yeah?
I actually have a question about this, about Google Maps. It can be considered, a web service provided by Google. If we are actually logged in with our Gmail account, and then we have already set some preferences on my preferred location or whatever, is actually getting something from a previous session.
Yes.
So
yes, that is session data. Yeah, you're right. You're right. So when I said Google, I meant just the search engine, the pure search engine. If I want to be frank, also the search engine now stores some session data. If you're logged in, then they track your search history and they track your whatever preferences. They know a lot of stuff about you. You're right, but the plain Google, if you don't log in, is really stateless, and that's the key ingredient why they are so scalable in the beginning. Now, when they are scalable, because they have huge computing resources and they can afford to do this, to keep also sessions about you. You're right. So you're right. But the plain search engine is actually stateless. Okay, but somewhere we need to keep the we need to keep track of the state, right? Because you want to interact when you interact with Google. Let's keep Google the search engine, and we are not logged in, right? If you go from one page of the results to the next one, there is state. So if you navigate to page number 2, you really want to have results of page number 2, and not again the results of page number 1. So you understand that state must be there somewhere. So the idea here with REST is, first of all, it's your business, meaning you are the clients. It's up to you to store the state. Okay, if we are in the web browser, the web browser gives a lot of help. And then there's a very easy way to do this actually. You use the URL of your search or whatever of your website, and you encode the state there. I don't know, now I don't want to go to Google, but if you Google, you go just to google.com, then there's only google.com as URL. You put your search, you hit search, and you see that the URL changes. So your search parameters go into the URL. And then, if you read them very carefully, then you will see that there is a lot of control information there. It's not just your search parameter, but there is then also information about which page you are on in the result set, or which number of items are there, and so on. You can even configure Google a little bit if you parse just the URL. So the idea is this: if you navigate to page number 2, you get another URL, and you only change the parameters in the URL. So it's all at the client side. It's all inside the browser. You go to google.com, Google answers with a web page and a new URL. Google shuts down. You keep the new URL in your web browser. You have links in the web page to page number 2, page number 3, page number 4. Depending on what you click, you issue a different query again to Google with, for example, the request for page 2, 3, or 4. And then you issue this request. Google wakes up again, reads your request with page number 4 there. Okay, when it doesn't know whether you are, when you invoke this, whether you are on page 1, 2, 3, or 100. It doesn't care. The important thing is only that you asked for the URL, or let's say for the search results of page number 4, and it computes the same results for page number 4. Full stop. This is the idea. So you encode all the state in the URL, and it's in the client side. As I said, if you do this in a web application, the browser is doing it for you. That's the good thing. So the browser has already implemented this logic, this URL forwarding and this URL encoding and so on. If you develop a piece of software, if you develop your own application that interacts then with a remote web service, if you want, that mimics a user and interacts with Google, then you have to program this behavior. You have to do this yourself. You have to be able to, let's say, invoke first of all the URL, then you get the result back. Then you have to be able to parse the result and to identify the links there. There will be links and references to other, as I said, result sets or other resources. And then you need to be able to extract these links and to invoke again new requests, and so on. And so you can, with a piece of software, just navigate through Google just like you do manually. The idea of RESTful services is that you implement this piece of software instead of for Google, just for a remote piece of software again, just something that has not a user interface, but only an XML or JSON interface for programming. So, to summarize a little bit, this statelessness is important. So what are we talking about? There are two different states, application state and resource state. So there's this example of Flickr. So each time, so the question is, would statelessness mean that I have to send every one of my pictures along with every request to Flickr? Meaning each time you have to go to Flickr and you want to see your pictures in Flickr, do you have to send the pictures together with the request? Of course not. You know, this doesn't make sense because the photos are the resources. So the resources are stored on the server. So each time you send a photo, you upload the photos, they are stored on the server and they are kept there. This is called the resource state. What the server does not store is your interaction with it, whether you are in the page with the overview of all the pictures or whether you are looking at one specific picture. That's your business. And this is called the client application state. This is the big difference. So resources are stored on the server. And resources, of course, they have a state. They are either there or not there. They may have their own life cycle, like photos. Maybe they are there, and then you still need to give them a name, and you need to tag them, and so on. That's server thing. The interaction with these resources is the client or application state, and this is up to you. And the example is more or less what I said before with the Google's browsing from page to page again. So statelessness applies only to the client application state. As I said, when you implement a service or a piece of software interacting with the RESTful service, you have to really manage this yourself. You have to talk in terms of URLs, and you need to know how to go further, to go to the next step with the URL. But you don't have to care about how the resources are stored. Once you send them, they will be there. And yeah, the first point here is maybe interesting. So a web service should only know about the client application state when the request is made. So what I said about Google, Google doesn't care about what you do in your web browser. It only cares about the URL you send. And this is what this sentence means. So the web service only knows about your state in the moment you issue the request. And this is the very idea that leads to the name of REST, which means representational state transfer. So in the URL, you have the state, and in the, so state is in the URL, and then you get a representation back. And that's it. So URLs and representations, they contain the state, not the server. Good. Some words about these representations. We have seen that resources can be of any type, books or so on. And the example of the researcher and or let's say of this Jane Doe and of the user profile was actually quite good. As I said, the resources, they are stored on the web server's file system or the database. And if you are the provider of that service, you don't give your clients access to your real database, and that's the, the asset you have. You only give access to some mediated format, which are the representations. And these representations can be of different types. That's very important. There are, as I say, there are XML representations or web pages or images and so on. And you can send these representations directly over HTTP then through the network. And representations flow in both directions. Think about Flickr again. It's true that if you invoke maybe a Flickr service, you get pictures back. But in order to get pictures back, you first need to upload them. So also, you as a client, you send representations. And then the server, maybe you send a new picture, and then the server, hopefully, creates a new resource for your picture, which means it stores your resource into the database you will never see. But you know that you push the photo there and it will be stored on the server. So it's resources, they flow. And resources, they don't have the big value. The big value is the resource stored on the server. So there are two types or two options, let's say, to decide which resource you want to have. Sorry, which representation of a resource you want to have. I told you these nice things, that there's a resource and you can have different representations. But what do you care? Maybe you want to have an XML representation and that's it. But if the resource gives you, let's talk just about the database. It gives you a JSON representation, it gives you an XML representation, it gives you, I don't know, a plain text representation. You need to decide, you as a client, you need to decide which one of these representations you want to have. You don't want to get them all. So you need to choose, and there are two key ways of doing this. Either you have simply different URIs for the different representations. In this case here, there's an example, you have representations in different languages, and each one is identified by a known URI. So this is one way of doing it. Let's say this part here, till 104, identifies the resource, and afterwards you add an additional control information to select the resource. This meets, of course, the requirements of addressability and then statelessness. It depends on how the server is implemented. And I don't know, it's one. Maybe we can discuss once we see the second option. Option number 2 is a bit more difficult to understand because it's harder to visualize like this. It is based on a dedicated HTTP method. It's called the head method. And what happens? There's a resource. If you issue a GET to the URI of the resource, you get a representation of the resource. If you only issue a head request, then you get only the metadata about the resource, and you get information about which representations of that resource are there. So you could, in this is just a control message, let's say. You invoke it, and then the server tells you which representations it has. Then you choose, and you put into your own GET request, you already say what kind of accept language, or this is more or less the parameter that you need to set, what kind of representation you want to have. The web browser typically asks for HTML pages, or it asks for JPEG images. And this is what you can, so to say, negotiate. So if you as a client ask the resource, which are the representations you have, then you can reason about it. You can say, okay, I would like to have this or that. Or you can immediately, let's say, issue, I want to have XML, and then the answer from the server would be, no, I don't have XML, I only have JSON. And then you say, okay, then give me JSON. The difference is that you would have only one URI, but you need to negotiate. You need to ask, what do you have? And then you need to say what you want, and then somehow you need to identify an agreement. Of course, as a client, you have to stick to what the server gives you. And it's called negotiation, but there's not much to negotiate. If the server only gives you XML and JSON, then either one of the two you need to have. The difference is this. Here, you need to know the URI of the resource representation that you want to have. Here, you don't need to know anything about the representation beforehand. You only know the resource, and this is the minimum you need to know, and then you negotiate the representation. So this is a comment that was already in the slides. Option 1 or 2 are both acceptable REST-based solution, and here but the addressable URI option is preferred, which is the first one. I don't know. So maybe this is easier to implement if you are a client, but it has problems. So the purists of REST, I know they are more for option number 2, because they say representations may change over time. And if I tell you that today this URI here gives you the French representation of this resource, maybe tomorrow I change my service, and this URI is no longer there, and the French resource moved to some other URI, then your client will break. The REST purists say this is bad design. You only need to know about the URI of the resource, and then you ask for it. And if today the server asks you answers with one URI then for the French representation, tomorrow it will just answer you with a different URI. But your client will not break. This is the idea. So if you don't use the prefixed URIs for the resources, the client is supposed to be more stable, but you have to implement the overhead of the negotiation. You need to talk to the server and negotiate. This is an overhead.